Hello and welcome to the sixth video of this Java lecture sequence. Today I'm going to be primarily talking about something called the while loop. Some of you may have heard of this before, some of you not. Either way, by the end of this video you should understand the basic principles of how it works and how we can usefully implement it in a program. Just a quick review, in the past we mainly looked at the structure of if-else statements and how those could be used to create logical systems that would respond differently based on a set of parameters that had already been specified in the program. And even in the future, we'll be able, as we learn more about Java and its object-oriented nature, we'll be able to use these if and else statements far more usefully, and we'll be able to greatly expand what we can do with them. So I'm going to clear everything out here. And we still have these operators down here that I just have listed for reference. And I want to make something that will print out, the numbers 1 through 5. And so I'm going to show you how to do this basically the brute force way. And so just think for a second about how you would do this if you had, no other training besides what you already know from the previous videos. If you want to print out 1 through 5, how are you going to do that? And so you could do something like this. Print out 1, and you could copy and paste this 5 times. Okay, and if you run this, then what you'll find is that you get the numbers 1 through 5 printed in the console quite nicely. And so that wasn't too terribly painful. But what if I asked you to print out the numbers 1 through 100? Or 1 through n, where n is just some number that you want to print out the numbers 1 through. What if it's unspecified? And so we need to be able to create a system that's flexible and can respond to changes in how many numbers we might want to print out, and also doesn't require another line of code for each number we print out. What if you want to print out 1 through a million? You don't want to have to write a million-line program and specify each number. And so the while loop is going to show us how we can kind of make use of that. So before I show you that, I'm going to introduce kind of the concept of a counter and how we can implement this. Use this first in our implementation with the brute force method, and then eventually in our implementation with the while loop. So I'm going to create an int, and I'm going to call it counter. And that's a name, and I'm using it just because it's going to count something. Or I'll even call it count, just so it represents the quantity. And I'm going to say that integer called count is going to be equal to 1. And so instead of printing out 1 here, I could print count. And if I run this, you'll see that I get the exact same thing. For the first one, we do get, this count here, because count is 1, and the rest of them are just brute forced. But instead, what if before I do the 2, I said count equals count plus 1. So it takes the current value of count, adds 1 to it, and now that's the new value of count. And so count is now 2. So now if I do count here, when I run this, I get the same thing. 1, 2, 3, 4, 5. Except now both of these first two were done by increasing the value of this variable. So all right, I'm at the start of my program, count's equal to 1. I print out whatever count is. Count is 1, so we print 1. Now I'm going to say count is equal to 2. So this doesn't print anything. It doesn't change anything externally as far as we can see. But internally inside the program, if I ask you what count is, it'll say count is 2 after this is done. So now we're going to print out count. And like we just said, count is 2. So we're going to print out 2. And the rest of them were done by brute force. But now I can basically expand this idea and after every single step, I can just say add 1 to the count. So count is 1, print 1. Now count is 2, print 2. Now the count is 3, print 3. Now the count is 4, print 4. Now the count is 5, print 5. And we'll run this and see, hey, there's our 1, 2, 3, 4, 5 again. Well, this doesn't look very useful because we now have used twice as many lines of code to accomplish the same thing. But fear not, because we will be able to implement the while loop to save ourselves from this repetitive madness. And so I'm going to delete some of these. And what the while loop does, I'll just show the syntax first without anything else around here. It's basically while some Boolean statement is true, do what is inside here. And so basically what we're going to do is, this is essentially an if statement, except it's a repetitive if statement. So if this condition is true, then do what's inside here. But now, instead of an if statement would say, if this is true, then do what's in here, and then carry on your merry way down here. But the difference is that this while loop says, if this is true, do what's in here. Now, check if this is still true, and do this again, if it is true. Now check if it's still true. And this will indefinitely, forever and ever, check if this condition inside here is true. And if it is true, it will run this over and over again forever and ever until all of eternity. But if the statement inside here is false, then it will not do what is inside here, and then you will carry on with your life as you read down more lines, just as an if statement would. But until this is false, you are stuck repeating what is inside here. And so we can make use of that, because when we looked at our code before, we had the same repetitive sequence. We said count equals count plus 1. And then print the count. Right? So we did that over and over again. Except, so now what we need to do is figure out a condition. And so what our condition is really going to be is that the count is within some number range that we want to print within. So basically what we can do is say something like, while count is less than or equal to 5, do this. And so let's trace what's going to happen. The count is 1. So we're setting this variable called count equal to 1. Is count less than or equal to 5? Is 1 less than or equal to 5? It sure is. So now we're going to increase the count by 1 and print out the count. Actually, this is bad, and this just shows that even when you have experience programming, you still make little mistakes like these and have to fix them. And so I'm a human too, so this is a good time to see this. You know, within that sequence, I had seen before that I increased the count by 1 and then printed again. But what's going to happen now is the count's 1, it checks that it's less than 5, it is, and now we're going to set the count equal to 2. And the first thing that you print out will be count after it's already been set to 2. So if I run this, I'm actually going to get the numbers 2 through 6. And here they are, 2 through 6. That's not what I wanted. So what happened here was everything basically got shifted. And so let's say count was equal to count, you know, because this gets increased each time. So finally, count was equal to 5. Is 5 less than or equal to 5? It sure is. But now I'm saying we're going to add 1 and then print it out. And so that's how we got our 6. So that's not what I wanted. So what we're going to do is flip the order of these guys. So now the count gets printed out before you change anything about it. And so now we start out with it equal to 1. Is 1 less than or equal to 5? Yes, it is. So now we're going to do what's on the inside. Print out whatever the count is, which is 1. So that's this 1 right here. And then, here, I'll run this so you can see it. 1, 2, 3, 4, 5. So start out with count 1. Is 1 less than or equal to 5? Yes, it is. So we print out 1. Now we're going to say the count's equal to 2, because 1 plus 1 is 2. Then it goes back up to the top. Is 2 less than or equal to 5? It sure is. So we're going to do what's on the inside again. Print out 2. Now the count's going to be equal to whatever the count was before plus 1. So that's going to be 3. And so you can see how that keeps going. But here's the super cool thing. Now, if I want to print something, if I want to print out the numbers from 1 to 50, all I have to do is change that to 50. And I will get this massive list of numbers from 1 to 50 just instantly. And I could even do, 1 to 500, and that would even happen pretty fast. Voila. All those numbers, 500 lines, generated that fast. Just by using this simple structure that checks a condition and then does something accordingly. And the usefulness of this comes in that the condition that we're checking is modified by the action itself. And so you're continually doing this feedback on itself, but once you get to this certain condition where the count is equal to 500, then it'll do that. But as soon as you tip it over, after the 500 one, it'll set the count to 501. And then you say, well, is count less than or equal to 500? Is 501 less than or equal to 500? No, it's not, so stop. And it'll just read, whatever's below it, which in this case happens to be nothing. And so the program will terminate. And so that's just one example of how we can use a while loop very usefully. And there are other types of loops, and there's actually another type of loop that is slightly more ideal for doing this. But this is a really good introduction to the while loop because you can see how the numbers relate to each other. Another example of how this could be used, maybe you have, maybe you're playing a game and you want to check, whether or not your character is alive. And you have some sort of, variable that, and it doesn't matter exactly how this happens, but let's say you have a variable that tells you whether you're alive. Boolean alive equals, something. Then you can basically say, while alive is true, then keep fighting. Or something like that. And, this is all just kind of pseudocode. It doesn't actually do anything. But just to see the structure, are you alive? Keep fighting. But maybe when you're fighting, you get hurt. And so that means you're not alive anymore. So now it checks if you're alive. No, you're dead. And so you're not going to keep fighting. And so you could have, another sequence that determines what happens when you're dead. And so just things like that, continually need to get checked. And as long as some condition is true, you're going to keep on doing whatever is on the inside. So I hope that was a useful introduction to the while loop. And in future videos, we're going to look at other loops and look at how we can put all these things together to create some super cool programs.